Hey physics peeps, we're going to determine acceleration from a velocity versus time graph, or speed versus time graph, however you like to say it. So, on a velocity versus time graph, or speed versus time graph, acceleration is equal to the slope. And we can find slope by using y2 minus y1 over x2 minus x1. And the units for slope would be the units for y divided by the units for x. So if I wanted to find the acceleration on this velocity versus time graph for this section, I just have to either find the slope, or I can take my first point of the section, second point of the section, and use y2. So I go to the second point and go to the y-axis, it's 50, minus y1, go to the first point, it's 0 on the y-axis, and then x2, go to the second point, down to the x-axis, it's 5, minus the first point, go down to the x-axis, and it's 0. You get 50 over 5, or 10. And my units come from my two axes. It's my y, it's meters per second, divided by seconds. I can have meters per second, or I could call that meters per second squared. Either way. But the greater the slope means that there's a greater acceleration. Less slope, less acceleration. Again, negative slope means I'm slowing down. We'll see examples of that. There's another way that we could do this as well, because we can use that same equation from before, that acceleration equals Vf minus Vi divided by t. You'll see me use this more often just because it's something we've used before, and you can get that right off of this graph too. Because when we say Vf, it's that final speed or final velocity. And the Vi means initial velocity. And the t is the time. So to find the acceleration, my final velocity is what my velocity ends at during that section. My velocity is 50 minus the initial velocity for that section. It started down here and its initial velocity is 0. Divided by the time. It goes from 0 to 5. You'll notice that it's the same thing that I get from before. It's 10 meters per second per second. And that's my acceleration. I could do that on some of these other problems too. Something like this, we can determine acceleration from. So if we apply that same equation at each section, like for letter A, the acceleration is final speed or final velocity minus initial velocity divided by the time. My final velocity, it ends at 15. My initial velocity, it starts at 0. Divided by the time, it goes from 0 to 1. And my acceleration ends up being 15 meters per second per second. For section B, there's two ways you could do it. If we did find the acceleration during this time, our final speed would be what it ended at. We'll change colors here. Our acceleration is the final speed. It ends at 15, if I follow it over here, minus its initial speed, and it starts, this section, it starts at 15. Divided by not 2 seconds, be careful about it. It started here and it ended here. So it's still only 1 second. But you'll notice that I get 0 divided by 1. My acceleration here is 0 meters per second, or meters per second squared. You also have a flat line. Its speed is not changing. So you could just say it's 0, and that's fine and not show the work. That's okay. But then our last one Letter C, if we wanted to find the acceleration here, we go from its final velocity, we use the same equation. The final velocity, if I follow it over, is actually 10 minus the initial velocity. It starts here at 15. And you're only doing it for that section. So you're not doing everything, just for that section. Divided by the time. Again, the time is not 3. The time, it goes from 2 to 3. It's still only 1 second. And here, make sure that you do the math on the top right. Sometimes we tend to do it really quick. This is -5 divided by 1. I get an acceleration of -5 meters per second squared. So my when I found the acceleration here, I got a positive number, 15. Remember, positive acceleration means that you're speeding up. That makes sense. Here we got 0. No acceleration means you're not changing your speed. That makes sense. And here we got a negative acceleration because we're actually slowing down. And that's what negative acceleration means. So that's kind of how we find acceleration off of a velocity versus time graph. And yeah, you'll be good.